Hello again. Welcome to another lesson in geometry. Today we are covering section 10-2, area of trapezoids, rhombuses, and kites. So you've probably learned about trapezoids in the past, but I doubt you've learned about the area of rhombuses and kites. So this will be a little bit new stuff in here. So remember, a rhombus is a four-sided figure where all of the sides are the same length, so all sides are congruent. It doesn't say anything about angles. And a kite has a four-sided figure where consecutive sides are congruent. We have two pairs of consecutive congruent sides, okay? Just two pairs, not all of them are congruent. And then a trapezoid has only one pair of parallel lines for sides, okay? So one pair of parallel sides only. All right, so is a rhombus a parallelogram? Okay, yes or no? And this is yes. We saw this yesterday in or last time in our notes. A rhombus is a special parallelogram where all of the sides are the same length. All the sides are congruent. Are all rhombuses squares? And this is no. If all of the angles are 90, then the rhombus is a square. But if the angles are not 90, it's not a square. So you can have a rhombus that's like a square that's been smushed. Okay? Are all squares rhombuses? This is yes. Okay? It's got all congruent sides every single time. Okay? Cross out a figure that is not a rhombus. So this one's a rhombus. All the sides are congruent. This one's a rhombus. All the sides are congruent. And this one is not a rhombus. Not all the sides are congruent. We have a 10 length and a 7 length. Okay. Vocabulary builder here. We have the definition of a kite again. Remember, a kite is a quadrilateral with two pairs of congruent adjacent sides. So these ones are the same, and these ones are the same. It looks like a kite. You can find the area of a kite when you know the lengths of the diagonals. Okay, that's going to be important for us today, is to be able to find these diagonals in the kite. Okay, the name of the quadrilateral is taken from the name of a flying toy that looks like a flying kite. Okay, so circle the kites here. This one's not a kite. These two consecutive sides are neither congruent, nor are these two consecutive sides congruent. So this is no. Same with over here. This 4 and this 2 are not congruent, and this 2 and this 4 are not congruent. So therefore, that does not have a pair of consecutive congruent sides. But this one does. The 2's are congruent, and the 4's are congruent. So it's two pairs of consecutive congruent sides. So there's our kite. The figure at the right is a kite. What is the value of x? Okay, so this is one pair of congruent consecutive sides. So these should be the other pair if it's a kite. So x should be 5. Okay, and we have to get an explanation here. And this is because a kite has two pairs of congruent adjacent sides. Or congruent consecutive sides. So sides that touch each other. Okay. All right, let's flip it over and see what's on page 2. Okay, at the top of page 2, we have theorem 10-4, which is the area of a trapezoid. It says the area of a trapezoid is half of the product of the height and the sum of the bases. So you've seen this formula before. So 1/2 times the height times parentheses base 1 plus base 2. So you have to add the bases together, the top and the bottom of the trapezoid, the two parallel sides, and then times it by the half, and then times by height. So times by half and by height. All right, so the bases of a trapezoid, remember, are parallel. Okay. And the height of a trapezoid is the perpendicular distance between the two bases. Okay. So let's see why this formula works. What I'm going to do is I'm going to cut this trapezoid in half, because that's what that half does. So we're going to go right where the height is and split it in two pieces. Okay. All right. And then if we take the top half and we spin it upside down and then reposition it, now we have a parallelogram. Okay. And this parallelogram, okay, has a base that is the old base of B2 plus this part that got split up down and moved here. So plus B1. Okay. And then the height of my parallelogram is half as much as it used to be. Okay. So This parallelogram now has a height that's been cut in half. So height times 1/2. So remember the formula for a parallelogram is to multiply the base, which is B1 times B2. That's this part, times the height. And the height of my parallelogram is half of the original height, so 1/2 h. Okay. All right. Problem number 1, area of a trapezoid. What is the area of a trapezoid with height 7 centimeters and bases 12 and 15? So remember, the bases are the parallel parts. So there's 12 and 15. And then the height is the perpendicular that goes between them. So my height here is 7. And we're trying to find this area. So this area is going to be 1/2 of the height of the trapezoid, and then times the sum of the two bases, 12 plus 15. So 1/2 of 7 times 27, okay? And half of 7 times 27 would be about 94.5. So this area will be 94.5 centimeters squared, okay? Exactly, actually. Problem number 2, finding the area using a right triangle. So we have a right triangle in here. It's the 30, 60, 90 right triangle as part of our trapezoid. And we could use that 30, 60, 90 triangle to find the current height of this trapezoid. But unfortunately, that's not what our question is asking us to do. Instead, it says, what if you decrease the height until angle P became 45 degrees? Okay. While angles R and Q both stayed 90, and the bases both stayed length 5 and 7. And then we're asked to find what is the new area of that trapezoid PQRS. Okay, so let's go ahead and draw that. So this would be our 45, 45, 90 triangle in here. This is going to be length 2. This part's going to be length 5. And this part's going to be length 5 still. Okay. All right, so we'll answer some questions here. This is still angle P, S, R, and Q for our vertices. Okay. Is angle P still a 45? If angle P is 45, is the triangle still a 30, 60, 90 triangle? And this is, of course, no. It's got a 45-degree angle in it. So is the triangle a 45, 45, 90 triangle? Yes, we have a 90 right here. And that means we have two 45s to make it work. Are the legs of a 45, 45, 90 triangle congruent? And it should be yes. It's one of our special triangles. Remember, a 45, 45 triangle has the extended ratio x, x, and x root 2. So the legs are the same. So our height of our triangle then should be 2, because one of the legs is 2. The other leg should be 2. Okay? All right, so we have to find the area now. So our first step is to write down the formula. Okay, so our justification for this is the trapezoid formula. So trapezoid area formula. Okay, and then we're going to plug in the parts we know. So we are going to do substitution here. Okay, so we are substituting 2 for the height, and then 5 and 7 for the whole base from the bottom there, 2 plus 5, okay? So 5 and 7 for our bases. All right, and then we're going to add together the 5 and 7, okay? And then we're going to find our product by simplifying. Okay, and when we're done, we get an area of 12 meters squared. Okay, on the top of page 3, we have theorem 10-5, area of a rhombus or a kite. So the area of a rhombus or a kite is half the product of the length of its diagonals. So you find the length of its diagonals, okay, D1 and D2, and then you times it by half. And here's why it works, okay? So we're going to look at the kite to show it. If you copy this piece, okay, and you do some flipping, so let's get that piece out of the way here. Okay, so we'll just scratch it off of here. And then we take it and we flip it around and move it. We can sit it right next to that one, and they'll form like a little rectangle. Okay. The same thing with this one right here. If we cut off this piece of the kite, okay, and we flip it around and slide it, okay, we can form another rectangle down here. Now this new rectangle will have one side of diagonal D1, which was the D2, which was the big one through the middle, Okay, and the other side isn't quite D1. Okay, the other diagonal, instead it's D1 times a half because we cut off half, the top half, and moved it down to the bottom half to form a rectangle. And something similar will work for a rhombus here too. Just cut off one side of it. You can rearrange them and fit it on the other side to make a rectangle that has one side of D1 and the other side half of D2. All right, so describe one way that finding the area of a rhombus or a kite is different from finding the area of a trapezoid. Okay, so certainly one way is we're now using diagonals, so nothing to do with the sides. Okay, so my answer might be something like this. You use the diagonals, not the basis. Okay. All right, so find the lengths of the diagonals of the kite and the rhombus below. So we're going to find out how long the lengths of the diagonals are. So in this one, this diagonal is a 2 and a 2 put together for 4. And this diagonal is a 2 and a 4 put together for 6. And this one here, this diagonal is a 3 and a 3 put together for 6. And this diagonal is a 4 and a 4 put together for 8. Okay. All right, so finding the area of a kite, problem number 3. Okay. What is the area of a kite with diagonals of 12 and 9 inches long? And below is one student's solution. What error did the student make? Okay, so what did they do here? Instead of adding, they should have been doing multiplying here, because our formula is area is 1/2 D1 times D2. Product of the diagonals, not the sum of the diagonals. Okay, so the student added the diagonals instead of multiplying. Okay, find the area of our kite instead. So our area is 1/2 D1 D2, which should be 1/2, and then that's 12 times 9. And this will make, let's see, 6 times 9 is 54. So half of 12 is 6, and 6 times 9 is 54. So the area of our kite is 54 inches squared. All right, let's flip it over and take a look at page 4. All right, so finding the area of a rhombus. So a rhombus has side lengths that are all 10. If the longer diagonal is 16, what is the area of the rhombus? All right, so let's put in what we know. We know that all the sides are 10, so we can put 10 in all these spots. And we know that the longer diagonal is, where is it? 16. So that means this should be 8 and this should be 8. A rhombus's diagonals are going to bisect each other. Okay. So remember, the rhombus diagonals of rhombus bisect each other and are perpendicular to each other. Okay. So we're going to form some right angles in here also. All right. So label the rhombus at the right. We've already done that. The shorter diagonal is going to be what? Well, let's see. The shorter diagonal is going to be x plus x, which is 2x in this case, because it's going to be this x here and this x here. All right, so we're going to use the Pythagorean theorem to find out how long is x. Okay, so what are we talking about? Pythagorean theorem, we have a rhombus. Yeah, but inside this rhombus are right triangles. Okay, so in this right triangle here, we have 8 for a leg, x for a leg, and 10 for the hypotenuse. So we can do x squared plus 8 squared equals 10 squared to help us find what x is. So this will be x squared plus 64 equals 100, or x squared equals 36, and that means x is going to be 6 in this case. Okay. All right, so find the area of our rhombus. So that means that this is a 6 and this is a 6. So what are our diagonals? Let's see if we can figure that out. So rhombus has the same formula as a kite, d1 times d2, and then half of that. One of our diagonals is going to be 8 and 8 put together for 16. And our other diagonal is going to be 6 and 6 put together for 12. So our area is going to be 8 times 12, which is 96. And this is going to be centimeters squared. All right. Okay, as always, when we get to a lesson check, you should pause the video, try it yourself, and then come back. All right, so welcome back. Do you need to know the links of the sides to find the area of a kite? Explain. All right, so cross out the links. You do not need to find the area of each triangle in a kite. Which do we not need? Well, we don't need the hypotenuse in the kites. So each triangle in a kite is formed by part of the diagonal here and another part of the diagonal here. Okay, that's not the whole diagonal, but part of it. And then we don't need this part across here, which is the hypotenuse. That happens to be the side in my kite, right? Because our kite's formed by this triangle here and another one there. And all we really need to know are these guys, the diagonals, not the sides. So answer the question. And it should be no. Okay. Each side of a kite is the hypotenuse, okay, of a right triangle. Okay, you only need the legs. Okay, and that's because they form the right the diagonals. Okay, so the legs will form the diagonals. So those are the parts that we need. So we need this leg and this leg so we can get diagonal 2. And we need this leg and then this leg of the other right triangle so we can get diagonal 1. Okay, so we don't need any of the hypotenuses of the right triangles formed there. All right, so check off the vocabulary words that you understand here. Hopefully you know what a kite is. And hopefully you know what the height of the trapezoid is, which is the distance between the two parallel sides. And then can you find the area of trapezoids, rhombuses, and kites? Probably you didn't know these two before now, but you should know them pretty well by now. Okay, they're both the same. 1/2 diagonal 1 times diagonal 2. All right, I'll see you in class next time.